So thus far, we have combined a 1s orbital and a 1s orbital. And we've also combined a 1s with a 2p. In this lecture, we're going to combine a 2p with a 2p to form molecular orbitals. Now the first thing we have to realize is that there are at least two different ways that we can orient our 2p orbitals. In part A, we have a parallel orientation. In other words, our 2p orbitals are simply parallel to one another. In part B, we have an orthogonal or perpendicular orientation in which our one 2p orbital is perpendicular to our second 2p orbital. So let's see which one of these forms molecular orbitals. So let's begin with part B. In part B, we have two ways that we can orient or combine them. We can either combine the positive of this with the positive of this, or we can combine the positive orbital here and the negative orbital here. Negative simply means we flip the signs. In other words, this green is the positive, this green is the negative. So let's begin by adding or by combining the positive 2p and the positive 2p. We get the following orientation. Now notice in this orientation, we have the positive interacting in a bonding way with the positive, and so that forms a bond. And here we have an anti-bonding interaction because the negative of this 2p orbital interacts with the positive section of this 2p orbital. So we have bonding and anti-bonding. So let's look at the negative, or simply we're combining 2p positive and 2p negative. That means this becomes blue and this becomes green. So we have this orientation. Once again, we have a negative interacting with a negative, so that means we get a bonding orientation, and we have positive interacting with a negative to produce anti-bonding. So that means because we have bonding and anti-bonding, we have no net interaction. In other words, no net interaction because the bonding and the anti-bonding exactly cancel out. So this type of orthogonal orientation does not work. It does not create molecular orbitals. So let's go to the parallel. So once again, in the parallel combination, we have two different ways that we can combine. Remember, we're inputting two atomic orbitals, so we should get back two molecular orbitals. So let's go this way first. In other words, we're combining a 2p positive and a 2p positive. So we get this orientation. Notice we have positive interacting with a positive and a negative interacting with a negative. So we have bonding interactions. Likewise, if we combine positive 2p and a negative 2p, we switch these guys. So this becomes a negative blue and this becomes a positive green. And we have this orientation. In this orientation, we have positive and negative, so we have anti-bonding and anti-bonding. So there exists a nodal plane smack between these two guys, right in the middle. So that means there's no electron density here, so electrons can't be found on this node or nodal plane. So this in fact creates this type of parallel orientation, creates two molecular orbitals, one bonding and one anti-bonding. So let's draw our energy diagram. Once again, going up, our energy increases, going down, our energy decreases. So, since our 2p orbitals are exactly identical, that means they're on the same energy level, so they're on the same level here. Likewise, because they're identical, they each have one electron. Now, these two electrons will want to go in this orbital or in that orbital. Well, probably this one, and that's because this one is more stabilizing. It's stabilizing because it's lower in energy, and nature likes that. Nature creates a system in which the energy is lower than before. And so our electrons will combine to form our bonding molecular orbital. And notice that the spins are different, they're opposites. And this fact is due to the Pauli exclusion principle that states that any orbital has a maximum of 2 electrons, and these 2 electrons have opposite spins. Now notice that electrons can still go into this orbital, right? But they don't want to. And so that's why you won't find electrons there. If the electrons do somehow end up in this orbital will create a destabilizing effect. And that means the nuclei will repel one another and will try to break that covalent bond. So that's exactly why electrons don't like to be in this anti-bonding orbital, because anti-bonding orbitals destabilize the bonds because the energy is higher than both the beginning atomic 2p orbitals and the final bonding molecular orbital.